Hi, I'm Nick with Duramaxtuner.com. I'm here with Jason Wherli again. We're at Kevin Engelking's dyno in Freeport, Illinois. We have a 3.0 sled motor on the dyno today, and we're just going to kind of do a little walk around and show you what's new and cool for this year. This is a pretty serious setup, 3.0 truck. The main goal of this class is to get as much air as we can through a 3.0 inch opening, just fuel the ever-living hell out of it.
Yep.
And go to the moon, right?
Yep, pretty much the restriction in the class is the 3-inch inducer on the turbocharger. So
okay.
that's our biggest restriction.
And
cubic inch of the engine, we're allowed 450 cubes.
Okay. Tell me some of the new technology we have for this year. Let's start with these fuel pumps.
Yeah, the newest thing, the newest design and creation we have at Wherli Custom Fab is this triple CP3 pump setup. Generally, you'll see three CP3 pumps driven off the serpentine belt. What we did here is we have a cog belt system off the front of the crank to drive all three pumps. They're all close together. All your lines are short. Fuel lines for the high pressure and low pressure side are all short lines. And everything's more compact. You have a more secure setup and a better drive using the cog belts versus serpentine. You don't have to worry about any pumps slipping or not spinning correctly.
So each pump about 20 horsepower?
Yep, these are 3 stock pumps. They're not modified pumps. The stock ones are more reliable.
Okay.
And the stock pumps at full load will draw roughly 18.5 horsepower. So you're just shy of about 60 horsepower getting driven off the front of the crank right here.
So that's a lot of horsepower
Yep.
worth of fuel.
Yep.
Okay, and then you guys made your own fuel rail setup that's behind this?
Yeah, we actually incorporated a third fuel rail. Instead of having just the 2 factory ones off the heads, we have a third one over here.
Okay.
Mainly in a sense, all the pumps feed that rail, and then from that rail it feeds the injectors.
Okay.
This allows more fuel volume, so when you're at the high RPM output, you have more volume on hand, and it just makes things more compact instead of having lines running all around the motor and crisscrossing over everything. They all run to that rail and then disperse.
Okay, so while we're talking about RPM, this engine is designed to operate in a fairly narrow RPM window.
Yep.
You were going to set the gearing up in the transfer case to make sure that it falls in that RPM window. What's our RPM window that we're designing this engine for?
Every truck's a little bit different. It all comes down to how the turbocharger likes to run down the track.
We're going to find out as
the turbo. Yep, we'll find out when the pulling season comes. But in general aspect, our other truck that we have out that's been pulling, they generally run down the track at about 3,800 to 4,200 RPM within that window, and then at the end of the track they'll get drugged down to closer to 2,800, 3,000 RPM.
So that's where we're shooting. I mean, our peak power number is going to be mid-3s.
Yes, your peak horsepower is going to be in the mid-3s, and obviously your torque's just going to climb the lower you get with your RPM.
Sure. So this whole system's designed to run in that 3,000
yep,
to 4,100,
between 3,000 and
RPM.
4,000 RPM is where you're going to see all the peak power.
Okay. Next thing kind of staring me in the face here is this intercooler setup.
Yeah, that's quite a design that we just came out with this year. It's got a highly advanced high flow lower portion on it with CNC machined plates that for all the air to flow evenly into the cylinders, into the runners. It's all CNC flanged. It's all TIG welded together. It's all TIG welded on a jig for proper fitment and flat sealing surfaces.
Now obviously we're running 50, 60 pounds of boost, but even so, all the air doesn't get into each cylinder the way that it should. So design of the lower runner system is important.
And with this setup, with the core being on the top, the core evenly displaces the air through the core, which is sitting directly above the intake, and that helps displace the air into each cylinder more evenly.
So we got good distribution.
Yes, good distribution. Yep.
Okay. Awesome. I see. I mean, it also is a fairly short, as opposed to the last motor that I saw in here where we had intercooler over there plumbing all the way across, we had quite a bit of volume display, this is much less.
That's another great thing about having the intercooler incorporated into the intake is you eliminate one intercooler pipe, you eliminate several boots and clamps that can cause boost leaks. So we pretty much have a compressor outlet with solid O-ring flanges on both sides. There's no possible way for any boots to pop off, any boost leaks to happen right into the intake. So it's a nice short run.
Yeah.
4-inch pipe, more volume.
Awesome. Size of the intercooler core, we're expecting a very low.
Yeah, we're not sure what this charger is going to put out for temperatures yet. Our previous engine we had on the dyno was putting out close to 500 degrees on compressor outlet air.
Okay.
After that air passes through the core, which has ice cold water running through it, we were seeing 68 to 75 degree temperature entering the motor. So that's a huge horsepower gain.
Mid 300 worth of heat.
Yep.
I mean,
we're taking
a lot of heat off this motor.
400 degrees out of it.
Where is that heat going?
That heat is coming through the exhaust, obviously, once it passes through the motor.
Let's talk about the intercooler.
Heat,
so we got a pretty elaborate system here. To
what
bring
you have
out
here
of it.
is you have a water box. This box in particular is actually right off of the pickup truck, or right off the pull truck, and you have some submersible water pumps in here, which is full of ice and water, bringing the ice cold water through the core, which then it enters the low side. That way it allows the core to completely fill up.
Okay.
Comes out this side and then back through. It's just a big,
so we have
big
two
circulations.
feed, what
Two
size are these?
Inch and a
5/8?
quarter, 2 inch and a quarter feeds.
Okay.
2 inch and a quarter outlets.
Okay.
So you're moving,
Moving a lot of
we're
water.
moving about 30 gallons a minute through this intercooler core.
Okay.
30 gallons of 32 degree water, 34 degree water. So
Impressive.
that's where you're achieving your main cooling on your intake air temps.
Let's take a walk around and show the exhaust system. So obviously we have the header over here, and we have a lot of sensors coming off this thing. Quite a few EGT sensors, drive pressure sensors. We're going to have no shortage of data from this engine dyno.
Data is the most important thing when it comes to truck pull, and knowing what the engine's doing and to make sure it's running in, for the most part, safe parameters, and to be running at its max power output. So we watch EGTs off each cylinder to make sure each cylinder is running within a certain temperature of each other. Here we have drive pressure to measure the exhaust pressure, where we're also watching boost off the turbo as well.
So that's going to let us, that drive pressure is going to let us know, did we choose the right exhaust housing? Are we running the engine in the right power range? We have all that data from the engine dyno run. It's important to be able to compare that to the track data.
Instead of testing all year long in the truck, we get it all figured out at the dyno. Right. We also have on the back of the intercooler here on the intake is a pressure sensor and a temperature sensor, so we can watch that in the intake air as well.
Cool. Tell me about your header design here.
This is a system I fabbed up, 1/2 inch thick flanges. It's all stainless tubing, 2 1/4 inch for maximum flow, and then they all have they're all bend, so they're flowing well versus a cast manifold that most people run. And then it's going through the crossover pipe here, 2 1/4 as well, with a expansion bellow just to keep everything allowed to move a little bit.
Okay.
Which is then feeding the one of the T6 openings on the back of the turbo.
And it looks like you used all GM flanges there.
Yeah, we use GM flanges so we can use GM gaskets. We try and keep that simple.
Gotcha.
You can have in stock and on hand.
Is there any issue running a 2 1/4 inch pipe through the factory GM gasket?
No, the gasket it actually clears fine. Yep, there's an opening there. It's big enough.
Cool. One other thing on the back here, we have our pressure relief system and our fuel rail pressure.
Yep, that's part of the high pressure system here. This is actually off
you have
of
this fancy valve here. Which
this is LB7 Duramax. So this valve is actually modified to instead of popping off at 24,000, which is where a stock one does, this one will pop off at 30,000. It allows us to run higher rail pressure.
Okay.
If this were to pop off, we're going to lose rail to the injectors, which is going to hurt our power output. So we raise that so that it doesn't pop off the pressure on us. It's just a safety feature we have.
Gotcha. We've taken our time, walked around the engine, seen what's new for 2013. A lot of cool stuff we're going to run today, assuming everything goes smoothly. I think it's time we fire this thing up, see where we're at, see if we got any leaks or anything else needs to be addressed before we start putting the heat to it. We got the motor fired up, but something doesn't quite sound right. We definitely have a miss. It's time to track things down. We have some diagnostic trouble codes we need to go over and see where we're at. The trouble code shows that we have a crank position sensor issue. We've traced it down to the wrong reluctor wheel. The LB7 has a 57 tooth, the LBZ has a 58 tooth. Unfortunately, both styles of engines are built in this machine shop, and the reluctor wheel got switched. So what we need to do now is get one of those teeth off of that reluctor wheel. Jason Wherli is going to drop the oil pan, grind one of those teeth off. We should be back in business soon. We got the engine running right, we got all the leaks sealed up. It's time for our first loaded test. We're going to do a short run just to make sure everything's in good shape. Kevin brings the truck up against the brake, starts to load it. Yeah, that exhaust is moving, doesn't look so good. Exhaust falls off, fills the dyno shop full of smoke. We're going to wire it up tight, get the right angle on the exhaust. Hopefully we don't see that again. We're going to do a full pass this time, 1200 RPM sweep, really run this thing hard and see what it's got. That first run sounded amazing. Very happy with where we're at on the truck right now. I'm just going to make a few changes to the fuel rate and the timing, see if we can't pick up a few horsepower. 8 hours on the dyno today, only a few of it actually running the engine. But once we get this thing loaded and running right, it is strong. I think we're going to see a real contender for the 2013 season here. Big numbers, we'll share them at the end of the season, but she's going to be a runner. This is Nick, thanks for watching.